All right. I want to again thank everyone for. Hello, everyone. I want to thank you all for participating in that little different activity that I gave you guys. With exploring on how to multiply and divide rational expressions on your own. Full disclosure, I was creating that activity to fulfill a requirement for my national board certification that I'm applying for. It's kind of like a national honor society for teachers. So I just thank you guys for participating in that and giving it, a good amount of effort at least. So I appreciate that. That being said, though, I do want to kind of like give you guys a full, lesson on this. Those of you that like went through things and you pretty much feel like you got it, feel free to skip through this and just go right to the homework. If you want to just skim through this, that's fine too. What I got for you right now, though, or 8 questions, and I want you guys to go ahead and just think, pause the video, think in your head, yes or no, can we add these things the way they are currently written? Or can we multiply these things the way they are currently written? So go ahead and just think about that. Just think yes or no in your head. Okay, so hopefully you had a chance to think about that. So here are our answers. Can we add 2x plus 3x? The answer is yes, and they are like terms. Right, they both have an x, they both have a single x there, so it gives us 5x there. Okay, can we add 2x plus 3y? The answer is no, not like terms. Okay, right, this has an x, this has a y, different things. Okay, apples and oranges, we can't really combine them together. I mean, you can, but then you're not talking about just apples or just oranges, you're talking about just fruit altogether, right? How about 1/3 plus 4/3? Can we add these together? And again, this falls back to what we were talking about last week with adding rational expressions. The answer is yes. Okay, they both have a common denominator. So this is like adding 1/3 and adding another 4/3, so we get 5/3. Okay, again, like terms. But how about 1/3 and 1/4? No, we cannot add them the way they are currently written. Okay, we have to get a common denominator. That's a strategy available to us to help us add these things. But as they're currently written, the answer is no, not like terms. Okay? All right, let's keep working here. Now, changing to multiplication. Can we multiply 2x times 3x? And again, the answer is yes. But notice I'm not writing like terms here. Okay, what is 2x times 3x? It's 6x squared, right? Can we multiply 2x times 3y? The answer is yes. We do not need like terms to multiply. So 2x times 3x is just going to be 6xy, and that's our answer. Now, the same thing holds true for fractions, okay? Just like we didn't need like terms to multiply, okay, we don't need fractions to have common denominators because that's like the like terms with fractions, okay? Same kind of concept. So 1/3 times 4/3, of course, we multiply across the top, we multiply across the bottom. Do not spend any effort trying to get a common denominator here. You just multiply the 1 and the 4, so that gives us 4, and multiply the 3 and 3, and you get 9. Okay, can we multiply, whoops, and I put the wrong thing here. I meant to put this. 1/3 times 1/4. And the answer is yes. Okay, we don't need common denominators to multiply these two fractions. We would get 1/12. Okay, again, multiply across the top, multiply across the bottom. That's the basics for multiplying fractions. All right, so do not, now could you get common denominators here and then multiply? Absolutely. Okay, so you could, if you wanted to, rewrite this, multiply by 4 on the top and bottom, multiply 3 over 3 here. You could say 4/12 times 3/12, and that would still be then 12 over 144, which would simplify to that 1/12. But why do all this extra work here when you can just multiply with the way it was originally written? Okay. So when it comes to multiplying fractions, there's kind of 2 main strategies I try to show you guys that you could take. Some of you guys already knew these strategies. Some of you needed to look a little bit more at them, but here's what I wanted to say. So one thing you can do is to multiply, then factor, then simplify. So I'll show you that. And I think a lot of people went this way, and this is kind of like how I led you down with that first activity that we did. So multiply first, so you get 20 over 30. Then you factor. So that means breaking down the 20 over the 30 into its, primes. And I mean, so it doesn't have to be the primes necessarily. So for example, 20 is 2 times 10, and 30 is 3 times 10. So you also could have broken down this way. That's fine. The 10s would cancel and giving you like leaving 1s behind, of course. And so that leaves 2/3. And of course, 2 and 3 you can't break down anymore, so that they factor, simplify. So there's the multiply, factor, simplify there. However, we could factor first and then simplify. So what I mean by that is 4 factors to 2 times 2. We have the 5, and 6 factors to 2 times 3. Now, you'll notice here that these 2's and the 5 are all going to multiply together, and these 5 and the 2 and the 3 are all going to multiply together. So we can cancel out these 2's, knowing they're going to already be 1 in the numerator, 1 in the denominator, and then the 5's can also cancel out because there'll be 1 5 in the numerator, 1 5 in the denominator. And so what does that leave? A 1 times a 2 times a 1 there, which is just 2. And what does that leave down here? A 1 times a 1 times a 3, which is just 3. And we get the same exact answer as before, okay? But it keeps the numbers smaller, okay? So this is what I would encourage you guys to try and do first. Simplify, factor/simplify first, and then do your multiplication. It keeps the numbers smaller. So let's see an example of that now with an actual rational expression. So here we go. Again, you could, if you wanted to, take that 3x squared, distribute it to all 3 terms here, okay, and then, try and factor from there. And you could do the same thing here. Multiply this trinomial times this trinomial and get some, massive problem. However, I would encourage you to try and factor first. So let's do that. So we get 3x squared over x squared minus 2x minus 8. So that's going to be x minus 4 and x plus 2. Okay, and this is why we spent so much time factoring quadratics, in an earlier unit, and also factoring polynomials in an earlier unit, because we need it for this right now. Okay, so it's going to be, continue to be useful. Those who are taking calculus, you definitely want to make sure you can add and subtract, multiply and divide irrational expressions. Okay, and get common denominators and stuff like that too. All right, factor in the numerator, I can take a 2 out, which leaves behind an x squared minus 3x minus 10. I'm going to go ahead and then factor that. So that's going to be x minus 5, x plus 2. And then the denominator will factor to be x minus 5 and x plus 2. Oh, okay, yeah, we can see that cancels there. So what cancels? All right, so we can, boom, x minus 5's go, x plus 2's go. And now we have a much easier time multiplying. What's going to be in the denominator here? It's just a 1. In the numerator, it's 2 times 1. And so we'll have 3x squared times the 2 times the 1. So it's just going to be 6x squared in the numerator over, and this denominator all canceled here. It's just a 1, so we just have this x minus 4 times x plus 2. It's up to you at this point if you want to actually then multiply these two things back together. I'd say don't. You can just stop right there and say there's our final answer. Okay, and again, your excluded values here would be x cannot be 4, x cannot be negative 2. Okay? And I guess technically from the earlier problem here, we also don't want x to be 5 as well. Okay? So, moving on. Let's try this next one here. X over 9 minus x and 3x minus 27 equals over x plus 1. This is even more simple. So we have x over, let's see here, 9 minus x equals, I can take a 3 out of this one. That's the only thing I can really factor. Woo! Oops, accidentally hit search. Okay, I can take a x, like I said, out of this one here. So that will leave us with, it's not equal to 3x minus 9 over x plus 1. Okay, now, do these two things cancel? No, not as they are currently written, but they are very close. In fact, they are exact opposites of each other. What can I do to make them exactly the same? Well, if I factor a negative 1 out of this, and I'll show you over here real quick. So 9 minus x, take a negative 1 out, leaves a negative 9 plus an x, like that. Okay, which negative 9 plus x is the same thing as x plus negative 9, but isn't x plus negative 9 the same thing as x minus 9? And so there it is. 9 minus x is the same as negative 1 times x minus 9. And so that's what we'll write right here. Okay, just flipping around that order by factoring out that negative 1. And now we can cancel out the x minus 9s. Now what about this x and the x plus 1? Can they cancel? And the answer is no. X plus 1 does not divide x evenly, so we just have to leave it. And so we're going to have 3 times x over negative 1 times x plus 1. And there is our final answer. And again, what excluded values? X cannot be negative 1, x cannot be 9. And again, that 9 comes from there. We don't want to have, if x is 9, we could divide by 0. We don't divide by 0. All right, now what about division? So division, well, if you can do multiplication, you can do division. Because any division problem, anytime you divide by a fraction, okay, that means like if I have 3/4 divided by 1/2, or 6x over x minus 30 divided by 9x squared minus 27x minus 36 over x squared minus 10x, whenever I'm dividing numbers, instead of dividing, I can always change it to multiply by the reciprocal. Okay, and so that's what we're going to do. Okay, now you can actually like do fraction division just like we do fraction multiplication, you know, if you're interested in this. So let me show you what I mean. So I'll finish this problem right here. Again, I'm changing it to multiplication by the reciprocal, and so we get 6 over 4, which simplifies to 3 over 2. However, if you do 3/4 divided by 1/2, and you do the division like we do multiplication, where you divide across the top and divide across the bottom, you will still get the correct answer. What is 3 divided by 1? It's 3. What is 4 divided by 2? It is 2. And hey, look at that. We get the same answer as we did right there. So you can divide across the top. The only catch is, how are you going to divide this across the top? How are you going to divide this across the top, or across the bottom, right? It doesn't really simplify nicely. So we'll just change it to multiplication. And I'm also going to go ahead and factor things too. So, and let's see, I'll take the 9 out, which will leave me with x squared minus 3x minus 4. And so I'll have x minus 4x plus 1, like that. Okay? Now, looking here, this does not factor or simplify at all. So we'd actually have to multiply this all out. So here's what I'm going to do. I'll go ahead and multiply the 6 and the x to get 6, or 6x to the sum of the x to get 6x squared. Okay, over, and then I'm not going to multiply out this junk. This is just too much. So I'll just leave it like this. And there's our answer. Okay, excluded value still. So x cannot be 30. X cannot be 4. X cannot be 1. Or negative 1. Okay, so there are our answers. Okay, now whether we need to worry about this guy up here too. I don't think so, because when we rewrite it, it's equivalent to this right here. So I don't think we need to worry about the 10s there. Yeah, I think we'll be okay there because of the reciprocal. All right, last one here, and I'm just going a little over 10 minutes, but that's okay. You forgive me, right? Okay, I hear you through the screen, and I heard you say yes. So again, we'll just change the division to multiplication and do the reciprocal here and factor as well. So let's see here. We have x plus 3, x minus 1 over factor out of 2, x plus 3, like that. Okay, only thing that factors here or cancels is the x plus 3's. And so we still have x plus 11 times x minus 1 over 8x. Okay, so at this point, yeah, we can just leave it like that if we want to. So x cannot be 0 here, and x cannot be negative 3. Okay, and there's our answer. All right, send me a message on the Schoology if you guys have any questions. I'll post your assignment for Monday. We will practice this one more day officially now, and then tomorrow we'll look at solving irrational equations. All right, so thanks, guys. Have a good day.